Spain has the world's second largest high-speed railway network, spanning over 2,230 kilometers, making it a global benchmark. As well as being one of the fastest, safest, and cleanest methods of transport, the high-speed train, or AVE as it is known in Spain, enables travelers to overcome orographic barriers, connecting cities in strategic locations. The Basque Country, with its mountainous landscape, is one of the areas in Spain that most requires versatile and innovative solutions. ACCIONA Infrastructuras, with its extensive experience in civil engineering and building of transport infrastructures, is in charge of executing an especially complicated section of the Vitoria-Bilbao-San Sebastián line, which crosses the provinces of Guipúzcoa and Álava in the municipalities of Escoriatza and Aramaio. The project consists in the construction of 3 viaducts and 4 tunnels along a 5.5 kilometer long section in an area where there are significant variations in altitude. The 3 viaducts span a total of 1 kilometer and directly connect to the tunnels, which in total cover approximately 3.5 kilometers. Given the size of these tunnels, with excavation areas in the order of 120 to 140 square meters, these have been built using the top heading and bench method. This method consists in dividing the section of the tunnel and excavating it in 2 phases. The first phase is known as the top heading phase, where the dome of the tunnel is built. The tunnels are supported at the same time as the excavation is carried out, before the following step. The new Austrian method has been used, which comprises pins, trusses, and sprayed concrete. Once the tunnel has been excavated in the top heading phase, the excavation and support phase, benching, start, which completes the excavation of the section of the tunnel. The support section is closed off with an inverted arch, formed by a concrete slab and lath. The construction process continues with earthing and waterproofing the tunnel, covering the section in its entire perimeter. The lining machine can spray concrete on up to 12 meters of tunnel in one go. It is put in place using provisional rails in the area where the concrete will be sprayed. The machine adjusts to the shape of the tunnel using hydraulic mechanisms and acts as a mold that will be filled with concrete. It is kept in that position until the concrete has cured. Once the concrete has cured, the machine moves on to the next section, leaving behind another section of the tunnel ready for its finishing phase. Under the filling concrete in the inverted arch and pavements, the PVC pipes and chambers are installed to form the tunnel's drainage system. Although it can vary, the construction process for viaducts always has a common element: the deck launching system patented by ACCIONA, capable of industrializing the launching process cleanly and effectively. Once the viaduct piles have been built and the work platform has been prepared, construction starts on the first segment, using formwork designed especially for this purpose. After the entire frame for the new segment has been built, it is placed with a gantry crane in the formwork, and it is prepared to be sprayed with concrete. After it has been sprayed with concrete and the formwork elements have been removed, the segment is pre-stressed, which will provide it with the necessary consistency to withstand any expected stresses once it has been placed in its final position. Prior to the launching, it is necessary to install the so-called viaduct launching nose, which, anchored to the first segment, serves as a guide during the entire process, preventing accidents from happening and making it possible to overcome the viaduct piles safely and efficiently. A hydraulic system located in a pit adjacent to the formwork will be used to move the new segment some 20 meters, leaving enough space to build the next segment. The system consists of a flat bar perforated every 50 centimeters, plus an element which is anchored to the segment and makes the system move forward by means of 2 hydraulic jacks, aided by 2 pins that alternately block one or the other part of the system. The moment when the nose reaches the piles requires a special level of precision. This construction process is made possible thanks to surveying into the hydraulic system, which is integrated at the end of the launching node. The job of this element is to correct the deflection of the viaduct using the hydraulic jacks in such a way that the nose passes gently over the provisional supports, avoiding the possibility of any collision against the pile, and guiding the rest of the deck to ensure it does not move during the launching. The deck launching concludes with the arrival to the other side, when the launching nose is dismantled. The replacement of the deck supports is made using portable hydraulic jacks that are placed so as to eliminate any pressure of the deck on the provisional supports. These are then replaced and the definitive supports are installed. Once the definitive supports have been installed, the finishing phase starts with the installation of pavements, railings, noise pollution protection, ballast guard curbs, and lengthwise cable conduits for the communication cables, leaving the section prepared for the future installation of the train tracks and the overhead lines. Completing this new section of the AVE in an area with such complex orography once more proves ACCIONA's capacity for undertaking projects of this nature, delivering the highest levels of quality. It has already built more than 1,200 kilometers, remaining faithful to its greatest corporate commitment: respect for the environment.